So now let's take our attention towards the embers. As always, we want to take a look at reference before we dive into Houdini, get a bit of a game plan together, and then do stuff. So what I first of all observe here is that with these embers, there's two main portions of this. We have the embers that are fairly consistent, and you can see these particles, they pretty much emit continuously for the most part. So we can get away with just a standard particle sim for that. And then there's also times where a log might move around, or let's say that there's some sort of pop in the fire, and there's these bursts of embers that occur every now and then. So the way I see this, it would be easiest to create one particle sim that's just the consistent particles emitting over time, and layer on another particle sim which represents these bursts of embers. And we'll source both of those things from the areas of the logs that we've already painted with the flame field. So that's the main plan. Let's go ahead and do this real quick in Houdini, and then we'll comp it on top of the render. Let's start things off by creating a continuous stream of embers. So create a new GeoNetwork. We're going to call this our flying embers underscore geo right there. We'll color this a light green right there, and then create an object merge that brings in the logs. So we'll go to our OBJ level, and then in the pyro source right here, we want to take the logs after they've been painted by this attrib paint. So if we go down here, we have, I believe it's right around here, this attrib paint where we specified flame. Create a little branch off from here. So we'll create a null, like so. And we'll call this our embers. We'll call this our flying embers out. So we're going out to the flying embers right there. Color that black, and then drag that into the object. So now that we have our logs in here. Let's create a scatter, and then scatter based off of flame. So we'll say flame right there, like so. And then let's bring this force total count up to, I don't know, maybe like 10,000. Something like that. Let's also hide other objects real quick so that we end up with something like this. These points right here are the candidate points that an ember is allowed to spawn from. Now let's create a pop net right here, and we'll call this our constant ember sim. That sounds about right. We'll do that. And then on this pop source, we'll say geometry source, first context geometry, and then we'll say points right there. So points, first context. And the last thing we need to do is bring in some sort of velocity field to advect these particles. And fortunately for us, we've already cached this out. So let's go back here. Let's create another object merge right there. And then let's go to our cache in the pyro imports and take the velocity that we're using from that. So I'm going to create a null over here. And let's call this our vel out. So we'll go like that. And before you get too far with this, be careful about something. Because remember how we took and changed the scale of these logs as we simulated things, and then we brought the scale back down with this transform? Well, that transform got transferred with this cache file, which means that right now we have logs which are about 1 meter in diameter, and we need to be sure that we match that with the velocity field that has the same transform. What that all means is that let's copy this transform, Control C, bring it over here, and then go down to invert transform and uncheck that. So that now this velocity field is at the same scale as our logs. Go ahead and plug that into the second input. So we'll go like that. And then to advect these points, we have a pop advect by volumes. Merge that in, and then say the velocity source is the second context geometry. But let's do this. Let's delete anything that we don't need. So we'll go right there, and then under the group, we'll say delete everything that's star except caret at name is equal to star anything with the term vel in it, and then end that with another star. So keyword is vel, and what we're saying is that look at the attribute name. If anything has this keyword in it, then don't delete that, but delete everything else. It's pretty much what we just said. Now if we middle mouse, we have vel.x, .y, and .z. Now if we go to our pop sim, and if we go forward a few frames, now our particles are moving along the vector values that occur within our pyro sim. And that's pretty cool. So now we have something like this, which is great. On the advect by volumes though, what you'll notice is that we don't have our particles moving very fast at first. And that's because we have this set to update force and treat as wind. And this wind is basically a force that acts on the particles over time. So as the particle moves further and further away from the log, velocity is applied multiple times. And what you get is a bit of a runaway effect. So what happens with these particles is that their velocity gets added with every single step. They start off slow, and then it adds and adds and adds until you end up with a really fast particle towards the end. So check this out. Start off pretty slow, and then it goes faster, 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 until once we get up here, these particles are moving way faster than the particles down here. And we don't want that, because that's not what our embers do. It's actually the opposite. These embers start really fast, and then they slow down. So to fix that, let's change this advection type to update velocity. And this will just take the velocity and apply it to the particles. Now let's also do something here, and that is affect this velocity blend. That is how much of this effect do you want, and let's set this to 1. By doing that, now the particles will adopt whatever velocity is present within the velocity field. So I'll just let this go forward a few frames, and now as you can see, we end up with something like that, which is good. That's exactly what our flames are doing. In the next video, let's dial in these different particle settings and then take a look at how to create those bursts of embers every now and then.